Welcome back to Demolition Worker. Today we tackle episode 35, focusing entirely on the complex electronic brain of an aircraft. The cockpit is where the most sophisticated technologies converge. Today we will carefully dismantle the absolute nerve center of this machine. This specific procedure requires extreme finesse rather than brute force. We must handle every single component with the utmost professional care. Stepping inside this confined space, you immediately feel the weight of responsibility that once rested on the shoulders of skilled pilots. These intricate panels guided hundreds of tons through the sky. Now, they sit silently, waiting for our specialized team to intervene. Before touching anything, our technicians put on special safety gloves. We must prevent any static discharge from damaging the valuable electronics. We illuminate the flight deck with bright portable lights, revealing the staggering complexity of switches, dials, and modern digital display screens. The center console houses the crucial thrust levers and communication arrays. We begin our meticulous assessment right here in the middle. To create enough room to work, we first need to remove the heavy pilot seats from their secure floor mounting tracks. These ergonomic seats are surprisingly heavy and feature complex mechanical adjustments. We slide them back carefully to avoid scratching the panels. Disconnecting the seat wiring harness takes a gentle touch. These wires powered the internal heating elements and electronic seat position motors. Two workers lift the captain's seat out of the cabin. It is a tight squeeze through the narrow, reinforced cockpit doorway. Next, we remove the first officer's seat on the right. With both seats gone, we finally have space to stand comfortably. Down by the floorboards, we inspect the heavy rudder pedals. These mechanical linkages connect directly to the aircraft hydraulic control systems. We use standard wrenches to unbolt the pedal assemblies. The metal here is incredibly thick and designed to withstand massive pressure. Pulling the rudder pedals free reveals a hidden layer of thick wiring bundles running underneath the main cockpit floor panel sections. We secure the exposed wiring bundles with plastic zip ties. Keeping the workspace organized is essential for a safe demolition process. Now we turn our attention to the overhead control panel. This area controls the auxiliary power, lighting, and internal cabin pressure. The overhead panel is held in place by dozens of tiny screws. We use powered screwdrivers to speed up this process. Carefully lowering the overhead panel exposes a massive network of colorful wires. It looks exactly like the nervous system of animals. We disconnect the primary wiring harnesses from the overhead unit. Each connector features a unique locking mechanism to prevent accidental detachment. The removed overhead panel is placed safely into a padded transport bin. We must protect these parts from any physical damage. Moving down to the glare shield, we find the autopilot controls. This module is relatively small, but incredibly dense with electronics. We unscrew the autopilot module and gently pull it forward. The golden connector pins shimmer brightly under our portable work lights. These gold-plated pins ensure perfect electrical conductivity during flight. Even a tiny loss of signal could cause a catastrophic failure. Now we face the main instrument panel directly ahead. This is the famous glass cockpit, dominated by large digital crystal displays. Older planes used mechanical dials, but this modern aircraft relies entirely on these sophisticated screens to display crucial flight instrument data. Removing these screens requires the precision of a skilled surgeon. We loosen the corner brackets and slowly slide the monitors out. Behind each screen lies a complex array of cooling fans and data cables. These displays generate significant heat during continuous operation. We label each screen before placing it into the container. Tracking the origin of every component helps during the recycling phase. With the primary screens removed, the dashboard looks strangely hollow. We proceed to extract the standby instruments located in the center. These backup instruments have their own independent power supplies. They guarantee the pilots can safely land if the main systems fail. We shift our focus back down to the center pedestal. Here we find the flight management computers, also known as FMCs. The flight management computer is literally the brain of the autopilot. It calculates the most efficient routes and manages fuel consumption. Typing on these keyboards feels just like using a classic calculator. The tactile feedback was designed to be felt through gloves. We unlatch the flight management computers and pull them upward. They slide out of their metal racks with a satisfying click. These heavy metal boxes contain multiple layers of dense circuit boards. They are incredibly valuable targets for our electronic recycling team. Next, we remove the radio communication modules from the pedestal. These units allowed the crew to speak with air traffic controllers. The radio panels are surprisingly lightweight compared to the computers. We swiftly disconnect their antenna cables and pack them away securely. We carefully detach the massive thrust levers from the central console. These mechanical arms controlled the raw power of the engines. The cockpit is nearly empty now, but our work continues. We must access the main avionics bay located beneath the floorboards. Opening the floor hatch reveals a dark and cramped compartment. This hidden area houses the heavy-duty processing units and routers. We climb down into the avionics bay with our tools. The air down here smells faintly of old machine oil dust. Racks upon racks of black metal boxes line the walls. Each box serves a highly specific function in the aircraft network. We begin sliding these heavy processing units out of their slots. They contain some of the most precious metals on board. Inside these unassuming set boxes are advanced circuit boards lined with gold. Palladium and platinum are also used in these grade components. We stack the extracted processing units near the main hatch. A hoist will be needed to lift them up safely today. One particular orange box catches our immediate attention in the dark. This is the highly resilient flight data recorder, the black box. Despite the common name, black boxes are actually painted bright orange. This makes them much easier to locate after a crash. We unbolt the flight data recorder from its reinforced mounting bracket. It is incredibly heavy due to its thick titanium armor. Right next to it sits the cockpit voice recorder unit. We remove this device with the same level of extreme carefulness. These recording devices are designed to survive massive impacts and intense fires. They hold the ultimate secrets of every single flight. We hoist the heavy recorders up into the main passenger cabin. Our team immediately secures them in specialized protective transport cases. Back in the avionics bay, we start cutting the main wiring bundles. Miles of copper wire snake through the aircraft fuselage. We use heavy-duty hydraulic cutters to slice through the thick cables. The pure copper inside is highly valuable for recycling. Pulling the severed cables out requires significant physical strength from everyone. We drag the heavy copper bundles toward the main exit. The avionics bay is finally stripped completely bare of all components. Only the aluminum structural ribs of the aircraft fuselage remain. We climb back up to the main flight deck level. The once majestic cockpit now looks like an empty metal cave. Stripped of its electronic brain, the aircraft is just an empty shell. It is a profound reminder of how technology evolves. We gather all the extracted electronic modules and load them onto trucks. They are heading straight to a specialized hydrometallurgical processing lab. Welcome to the high-tech electronics recycling and recovery laboratory facility. This is where the real magic of material science happens. Our technicians unpack the flight management computers on the stainless steel workbenches. We will now dismantle these boxes down to their core. Using electric screwdrivers, we remove the outer metal casings of the computers. Inside, we find tightly packed stacks of circuit boards. We carefully pull each circuit board out of the main chassis housing. The surface is covered in tiny microchips and resistors. A close visual inspection reveals the hidden treasure within these complex boards. The connector pins and processor sockets gleam with gold. Gold is utilized here because it is an incredibly reliable electrical conductor. It never corrodes, ensuring perfect performance in extreme altitudes. We also identify small ceramic capacitors that contain rare palladium and platinum. These precious metals are essential for stabilizing high-frequency signals. The technicians use pneumatic shears to cut the circuit boards into smaller pieces. This preparation step increases the efficiency of chemical extraction. These shredded circuit board pieces are loaded into a large glass reactor vessel. We are now ready to begin the hydrometallurgical process. A powerful mixture of strong acids is carefully pumped into the sealed reactor. This chemical bath will dissolve the base metals completely. The acid solution bubbles furiously as it reacts with the crushed copper and tin. We monitor the chemical reaction through the glass. Toxic fumes are safely vented away through a massive industrial air filtration system. Safety is always our highest priority in this laboratory. After several hours, the base metals have dissolved into the green liquid. However, the precious gold fragments remain entirely solid and untouched. We drain the acidic liquid through a fine microscopic filter mesh. The tiny flakes of pure gold are caught on the filter. The captured gold flakes are thoroughly washed with purified water to remove any residual acid. They look like sparkling yellow sand now. Next, we transfer these clean gold flakes into a small ceramic melting crucible. We place the crucible inside a superheated furnace. The intense heat quickly melts the tiny flakes into a glowing liquid pool. The bright orange glow of molten gold is mesmerizing. We carefully pour the glowing liquid gold into a small rectangular steel mold. It cools rapidly, solidifying into a beautiful metal bar. This small gold bar was recovered directly from the brain of an airplane. It is a perfect demonstration of modern electronic recycling. A similar chemical extraction process is used to recover the palladium and platinum. These rare metals are separated using highly specific precipitants. The recovered platinum powder is melted down into a shiny silver-colored button. This tiny piece of metal holds immense industrial value. Looking at these pure metal bars, it is hard to believe their origin. They once processed complex flight data high above us. We walk past rows of large plastic bins filled with stripped electronic components. These are the remnants of the once mighty cockpit. These complex control panels once guided hundreds of tons of steel safely through the sky. They sit quietly in these containers. The rapid pace of modern technological advancement is truly staggering to witness firsthand. What was cutting edge yesterday is simply scrap today. Dismantling a modern aircraft cockpit is not just about swinging heavy sledgehammers around. It is a highly delicate operation requiring extreme precision. Every single wire and circuit board tells a fascinating story of human engineering. We are essentially dissecting the ultimate marvel of aviation. By recovering these precious metals, we reduce the need for destructive environmental mining. We give these valuable elements a second chance today. The gold from the airplane might end up inside your next smartphone. The cycle of technology and resource recovery is endless. We take one final look at the completely empty shell of the cockpit. The electronic brain has been successfully removed and processed. Our specialized demolition crew packs up their tools and cleans the workspace thoroughly. Another massive industrial dismantling project has been completed today. The empty fuselage will soon be chopped into smaller pieces of scrap aluminum. That metal will be melted down to build machines. We are extremely proud of the meticulous work our dedicated team performs daily. Precision and patience are the ultimate keys to success. Thank you for joining us on this incredible journey deep inside the machine. We hope you learned something new about aviation recycling. There are always more fascinating industrial giants waiting to be carefully taken apart. We will continue exploring the hidden anatomy of technology. Be sure to tune in next time for another exciting and educational episode. We have plenty of massive engineering marvels lined up. Until then, stay curious and keep exploring the amazing mechanical world around you. This is Demolition Worker, signing off for now. Goodbye.